Hey there everyone. In today's class, we're going to look at some properties of solutions. Now, in your notes package, you should have a section that says properties of solutions, and I list 5 general characteristics or properties. I want to take a bit of time to just go through some of these together so that you have a better understanding of what these general characteristics are. So, the first general characteristic of a true solution is that the solute and solvent particles have to be mixed evenly together. So let's demonstrate this. We'll make a little legend here. Let's say that these black dots represent solute molecules, and let's say this larger open circle represents solvent molecules. Okay, so if you have two substances, so let's say you have a solvent, so their molecules are all of these open circles, and let's say we have a larger container between the two, and over here let's make just a general container, and this contains all of your solutes. Okay. Now the solute molecules don't have to be solid, but in our scenario here we can definitely make them solid. Okay, so let's say these are solid solutes. Okay, and this one here is a liquid solvent. Okay, if we were to mix them together to make a solution, you would have an equal or even distribution of both solute and solvents. Okay, so this is evenly distributed. If they were not evenly distributed, it wouldn't necessarily be a true solution, okay, like a homogeneous solution. It would rather be a heterogeneous solution. Okay, so just as a side note, if you have two solutions that look more like this, okay, you can see the solutes are sitting on top and perhaps the solvent is at the bottom. Okay, this would not be a true solution. Okay, because they're not mixed evenly together. Okay, so this is a no, this is a yes. Okay, because all of our true solutions are homogeneous solutions. So being a homogeneous solution, we also expect that none of these dissolved particles will ever come out of the solution. So I think it's also important for us to note that when they're separate as pure substances, you have a liquid solvent, okay, and a solid solute. They're not solutions, okay, because these are pure substances. And this is another pure substance. But when you mix them together as a mixture, then it's called a solution. So really, solution is just a fancy word for mixture. So when we look at property number 2, or characteristic number 2, dissolved particles will never come out of solution. So this is true for the most part. Okay. So if we have, let's say, a solution, and again, I'll use the same system. They're evenly distributed. Okay. Now, if I left it open like this, okay, let's say these are water molecules, and the solute ones here are salt molecules. Okay. If I just leave it open like this, in time it would evaporate. Okay, and if it evaporates, the water gets taken away, and then you get salt forming. So you don't have to wait till all the water disappears, okay, or evaporates. Even if half the water starts evaporating, you're going to find that there'll be salt particles or crystals forming at the bottom. Okay, so one way to make sure that this doesn't happen is to obviously put a lid on it. Okay, so right now, if there's no lid, no cover, okay, the water molecules might evaporate. If it evaporates, it'll leave behind crystals of salt. So salt will be left behind. Now this does take time. It doesn't happen right away. Okay, so if I'm boiling a solution, okay, the act of boiling it pretty much destroys what this solution is. Okay, evaporation is just a slower process. So when we look at this properly, in order to maintain it as a solution, we put a lid on top. Okay, so again, I'm just going to draw a few of them this time. I don't need as many. Okay, so here, water will try to evaporate, but can't, and it comes back down. It'll evaporate, and then it'll recondense. This solution will stay as a solution. It'll stay the way it is because the dissolved particles are not coming out of solution. Okay, so here we have no dissolved particles coming out of solution. Okay, and the main difference is just to put a lid on top. Now, if you have a lid on top and the substance still comes out of solution, then that wasn't a true solution to begin with. But if you have the lid on top and the particles stay in solution, then yes, we have a true solution. The third characteristic or property of a true solution is that it must be clear and transparent. Okay, so the mixture itself has to be clear and transparent. So a good test is to always see whether or not light can pass through a particular solution. Okay, so I'll draw a little flashlight here. It doesn't have to be a flashlight, it could be any kind of light source. And again, if we put our solvents, solvent and solutes, okay, because they're tiny, we normally don't see them. Okay, so we're zooming in, okay, so we can see these molecules, but if this was actually clear and transparent, then what happens is light should be able to pass through. Okay, so let's see if this works. So if I shone the light through this solution, it would go straight through. Okay. This would be considered a true solution. So light passes through. Okay. But let's say you have an opaque solution or an opaque mixture. Okay. Let's make it blood. Blood is opaque. You can't really see through it. It's not clear. Okay, it's not transparent. So this will be blood. And we know that this is a heterogeneous mixture. Okay, which we basically call opaque. So let's write that word here. So opaque usually means that there's some kind of solid suspended or floating in the solvent. So in this case, your solute doesn't really dissolve that well in the solvent. And if we were to shine on light now, okay, that light won't pass through easily. Okay. It may eventually come out a little bit, but again, it gets blocked by all the solutes that are not dissolved. Okay, it won't necessarily bounce back, but it just won't pass through to the other side. Okay. So light does not pass through easily. Okay, so this little test here, just by using light to shine through, similarly, you could also look at whether or not you can see through the solution to the other side, to see the images on the other side. If you can, okay, then it's likely to be clear and transparent. So all true solutions are basically homogeneous rather than heterogeneous. So moving on to number 4, the mixture cannot be separated by filtering. Okay, so this is a fundamental rule here. So if I had a solution, okay, again I have my solutes and solvents, okay, if I pour it through a filter, okay, so we'll say this is a filter. Filters generally separate solids from liquids. Okay. So if I pour this through, what comes out at the bottom should still be my solution. Okay. So none of the solutes and solvents have been separated. By filtering. So that usually means that if I pour something like blood through a fine filter, I should be able to separate something from it. Okay. If I poured sand and water, okay, which is not a true solution, okay, it's heterogeneous, the filter would filter out the sand and allow the water to go through, therefore separating the two. So this method, this mixture or this solution cannot be separated by filtering. And then finally, the solution must be in a single state or phase. Okay. This again refers to the solution being homogeneous. So homogeneous solutions are in a single phase. Okay. So when you look at something like this, okay, let's say we have water and we drop in a cube of sugar. Now, by the looks of it, we have more water than sugar. So water, in this case, will be our solvent. The sugar will be our solute. Okay. When the sugar breaks up, it'll break up into really, really fine particles, okay, that you cannot distinguish between water and sugar. Okay. So it would look like it's in one single phase. So sugar particles mix so evenly in between water molecules such that only one phase is seen. Okay. And later on, we'll actually look at this idea a little bit closer. And we'll actually look at what happens when sugar dissolves in water and what happens when salt dissolves in water. Because even though they both dissolve, they do dissolve in different ways. Okay, but for now, the fifth and final property is basically a single state. Okay, must be achieved when you have this solution or mixture. All right, that's all I have for today. I hope to see you guys soon. Thank you.